system. It's a creativity machine, and it forms a collective incentive for everybody to channel their energies towards basically solving hard problems. The Catalyst community is a complex, interconnected network. Proposers, implementers, community advisors, communicators, lurkers, community champions, all these different people interact in each other and influence each other in deep and profound ways. We're all pulling ourselves up and evolving together. Much like the dynamics of tree growth. In order to grow, be tall and resilient, it's actually essential that it grows at a slow and steady pace. They take hundreds of years to grow to their full size, but by that time, the fundamentals, the base is sound, and they can reach the top of the forest. This is very similar to what we're doing in Catalyst with our experimentation and also the careful building of the community and the systems and the tools. We're making sure that we're going to be the tallest, most sustainable tree in the forest. I remember meeting this chief innovation officer of a Fortune 500 company, and I was presenting him the tool to uncover problems in the organization. That he gave every employee the opportunity to express what they think is, what problems do I identify, and what kind of help do I need to perform well. And he was like, no, we can't do that. It will cause too much trouble for management if everybody is aware of all the problems we have and all the needs in the different departments of the organization. It's too much to deal with for us. One of the things I never got to do in Catalyst is, and I actually did doing my research, was deal with a lot of the psychological blocks people have about collaboration. And one of the major ones, the ability to express needs. You work in a traditional company, you are trained, I don't know what to call it, all a lifelong, you're trained to obey, you're trained to satisfy your boss. You're not supposed to say this is hard, this is difficult, this is uncomfortable, or I disagree with it. This is in a school environment. Can you do any one of these things? No, right? And this was our collective childhood at the family level, and your teacher level, in the kindergarten level. It's hard to say, but it's true, it's oppression, right? We've been oppressed very, very harshly since we were born. And everybody went through it, so everybody takes it as this is how it should be, or this is just the way things are. And what I realized in my research, even before my IOHK days, is that people don't even have the basic tooling to be able to express their needs. And I think over time we're gonna get there in Catalyst, because it's not just the technological transformation, it's a consciousness transformation. That's the big competitive advantage, of a system of Catalyst over other collaboration technologies, is that we don't ignore the full human behind the technology. We're not just thinking abstractly about incentives and system design and interfaces, but we realize that actually at the center of it is a human being behind these that needs to operate, that wants to thrive. And then you need to reawaken within you a part of you that is free, that is autonomous, that is self-determining, and it can't happen via a neat interface or by incentivize. It has to happen through a deep meaningful experience, a series of deep meaningful experiences between you and others that creates trust, that creates a sense of bond, that creates a sense of meaning. And then little by little it happens. The transformation comes from inside.
I guess, what does Catalyst look like, and also what does Cardano look like when we get to 1 billion users?
We don't know. We'll never know. It's the thing is that there's in paradigm shifts, and I show I have this little graph I show of Catalyst. There's a point when there's a phase shift when water becomes gas. Water becomes hot and hot and hot, more hot and more. Suddenly it becomes something completely different. Nobody knows the future, but my prediction is that by 2025 there will be a collective realization. Not in Cardano community, but around the world. There's actually an alternative to the existing governance systems, not because it's more moral or like the right thing to do, but because it's inevitable, because it produces better outcomes, it's more engaging, and actually that there was underneath it all a huge hunger, a thirst for an alternative. Those economical patterns, okay, of collaboration and human capacity for collaboration, it's a foundation, it's a base layer of everything. Everything comes based on top of that. That means that even a minor tweak on those fundamental primitives can cause huge change. There's gonna be another Cambrian explosion. But I think out of it would come something that we never dreamed is possible.
Hello everyone. Today I'm going to be walking you through how we're building the socio-technical operating system of the world. My name is Shruti Appiah. I'm the head of product for smart contracts at Input Output, and I have an extensive background in crypto economics as well, as you may know from my other work. And today I'm going to be talking extensively about smart contracts and how they will be used to build the operating system of the world of the future. So I'd like to give you a little bit of an overview of smart contracts first of all, and some of the properties that they have. So the first property of smart contracts is that they're frictionless and they're also quite accessible. So basically anybody that needs to be operating within a smart contract is able to access it fairly easily. So this allows for financial inclusion. It also allows for us being able to give economic identity to anybody that chooses to interact with smart contract. They don't need a lot of prior work in order to onboard these types of systems. That eliminates all kinds of barriers to entry, making this type of a system or this contract fairly accessible. The second property of these systems or smart contracts is that they are strictly enforceable. So since all of the rules and the logic of the system are embedded within the contract as code, these conditions definitely need to be met in order for the smart contract to execute and for the transaction to pass. So all of the conditions need to be met and they are strictly enforceable in that manner. This also, the special property of this is that it allows for us to eliminate any kinds of corruption that might occur in cases where a more powerful party or a more wealthy party might want to bully the less powerful party into submitting into a contract or satisfying some condition in an illegal manner. Thirdly, smart contracts are quite transparent, and this is one of the keys to having an equitable world because it allows us to be transparently viewing any kinds of exchanges that have happened between two parties, and these exchanges are also stored within an immutable ledger, so that means that the source of truth is always going to be trustworthy. And finally, I'd like to talk about, so on one hand we have smart contracts, and then on the other hand we have the rest of the world, which is already operating on quite a few legacy systems. How are we going to actually reconcile this? in order to build these types of systems, we need a lot of infrastructure. We need a lot of building blocks in order to build up the system in such a way that it will enable and it will interact fairly with our existing world. The first module that we need in order to enable this is programming languages. So we need a way to express the business logic, we need a way to express the rules under which the system will operate with. And for this, we need programming languages because the way that smart contracts are expressed is oftentimes in programming languages. So similarly to this, we have quite a few different programming languages that we're building here at Input-Output. We have Plutus, which is based in and embedded in Haskell. We have Marlow, which is also embedded within Plutus and Haskell, as well as several other domain-specific languages that we're developing for it to be interacting with other domains as well, such as supply chain, legal. We also have another domain-specific language called Glow. And we also have ways to interact with legacy systems and with legacy libraries and so on. So that's what Yelly is very good at doing. Secondly, we need a way for these programming languages to be interpreted by the systems that we already have. And for this, we need special infrastructure. So one of the first infrastructure that we need for it to be able to, for us to be able to write off-chain contracts and so on is Plutus Application Framework. Finally, we also need wallet backends so that our wallets through which people are interacting with are able to talk to decentralized applications that will be more user-facing. And finally, we also need several other kinds of infrastructure as they pertain to other languages as well. Thirdly, we need developer tools. And for this, we basically want ways to facilitate the development in such a way that development happens in a decentralized fashion, and that way we'll be able to not only eliminate redundancy, we also would need to make it easy for people to be developing on these platforms. And for that, we need libraries, so that way we're able to create modules through which many different systems can independently interact with. And then secondly, we need development frameworks so that we are able to develop in a more organized manner, as well as testing frameworks so that we're able to test our contracts as well as have some sort of a standardized way in order to ensure that all of these systems operate in a consistent manner. And then we also need integrations. So this really pertains to information sources and data sources through which several different developers can obtain their data from. And for that, we need integrations, we need sources of information as well, we need secure sources, such as we need trustworthy oracles, and we would need several other kinds of data sources, and we also need ways for which these kinds of systems can interact with other systems, so bridges, as well as other specific integrations just between applications. And then finally, we also need assurance. So security is primary to these types of systems. And there are many different ways to achieve security, and there's also many different challenges with security. So one of the ways in which we can ensure security is doing it by design. So security by design is one way in which we can ensure that programming language is secure. And so, for example, Marlow is secure by design, and that's because it imposes certain properties by the language itself that disallows certain types of security vulnerabilities from even occurring in the smart contracts that it builds. Secondly, we also need to ensure that the smart contracts that we have designed perform as they are designed. So that is where assurance and certification comes in. And for that, we have an extensive program in which we have developed 3 levels of certification. The first level being automated security and automated tools for ensuring that there are no race conditions and edge cases and so on. So basically doing all of the basic code checks. And we also have another way in which we are ensuring security, which is through manual audits. This is fairly extensive through the entire ecosystem. So manual audits are also key. And then we also need to mathematically verify that these systems work, and that's through formal verification. And finally, we have economic validation. Now, this is an area that I'm fairly passionate about, and this is also one of the most challenging areas to ensure that the systems actually work as intended. So this basically needs to check for incentive alignment. It needs to check if the economic behaviors that you have designed into the systems and the mechanisms that you have designed into the system will actually meet the goals of the system. The next thing that we need is, finally, we have actually now built all of these infrastructure, and we have built the core of the system. Now we need to have a way for users to be able to interact with the system in a fairly easy manner and in a fairly understandable as well as an accessible manner. And for that, we need usability tools. The first usability tool that we need is a way for decentralized applications to be able to interact with users, and that is typically through wallets. So we need wallets. We also need ways for these wallets to be fairly light and fairly easier to use, and for that we would need light wallets. Secondly, we also need identity, and that's because every user needs to have a single source of identity, and this will also help prevent Sybil attacks. And similarly with that, we're not just interacting with users, that being humans, we're also interacting with users that might be robots, that might be devices as well. And for that, we need key management, we need session management as well, so that we can automate some of these processes. And finally, we need interfaces. Interfaces are ways for any sort of end user or a device to be able to interact with a decentralized application. And one of the key examples of interfaces that we have built so far is Marlow Run, which makes it extremely simple and extremely easy for anybody to be able to interpret what a smart contract is saying and what kind of conditions and terms they need to meet. Now that we have users, we need to also question ourselves, how can we actually achieve adoption by more users, and how can we